Let's try using this concept of functions to look at a graph. Remember at the beginning I said that linear equations always represent functions. We know this because the input always produces exactly one output, and we actually have a way of testing it. We can use a vertical line test to determine if a graph represents a set of points that is a function. If a vertical line only crosses the graph once, then the graph represents a function. Just like in this case, we know every x value on this graph has exactly one corresponding y value. We know every input on this graph has exactly one corresponding output, or y value. So in this case, we know the graph and its linear equation represent a function. Here's a completely different equation that you've never seen before, and this is its graph. If we use the vertical line test on this function, we can see that it hits the function once here, and then the vertical line crosses twice at two different places. This happens for many points along the graph. So we know this graph and this equation do not represent a function. Let's move our vertical line a little bit back and look at it when x equals 4. So here's our vertical line, x equals 4, and I can see that I have 2 points on my graph. I have the point 4, 2 and 4, negative 2. Notice that the same input, x equals 4, produces two different outputs, positive 2 or negative 2. Again, this is why the graph is not a function.